Hey, so I'm Paul O'Neill, and here at Intel, I'm part of the Confidential Computing Group.
What exactly is confidential computing and why is it so important?
Okay, so confidential computing is an emerging industry initiative focused on helping to secure data in use using hardware-based controls. So, as we generally know, there are three stages in the data lifecycle: data at rest, data in flight, and data in use. So we've long understood that data should be encrypted when it's being stored, and we've known you should encrypt it when being sent across the network. But what about when it's being actively processed in memory? Especially today when systems are typically shared or even operated by a third party, public cloud, for example, like that. So protecting and creating confidentiality for data in use is this new frontier we're calling confidential computing. Now, thankfully, we're starting to see a lot more encryption of data at source, and this presents a problem that data needs to be decrypted to be processed. Confidential computing using hardware-based trusted execution environments makes it easier or lowers the risk of exposing it to the rest of the system during that decryption method, thereby reducing the potential for sensitive data to be exposed while providing a higher degree of control and transparency for users.
And how is Intel technology addressing confidential computing?
Um, to get a little bit more detailed into why we're kind of doing this, application data and even the code itself is under attack on a constant basis. Attackers can be hackers, they can be unauthorized third parties, or even malicious insiders. And by malicious insiders, people who have privileged access to machines. They can leverage exploits in other applications or privilege escalations in the operating system or hypervisor layers. They can use these to access private data, expose proprietary code, or even manipulate the results of computation. So we need to build a multi-layered defense in-depth strategy to make it cost prohibitive to execute these type of attacks. At Intel, we're very focused on building a layer of trust in the data center. Confidential computing built on a layer of trust down at silicon level brings a tremendous opportunity for application and solution developers to take charge of their data security using what we call hardware-based controls for cloud and enterprise environments. Intel has a technology called Intel Software Guard Extensions, or Intel SGX that we may refer to in the rest of this, which offers hardware-based memory encryption that isolates specific application code and data in memory. SGX allows user-level code to allocate private regions of memory that we call enclaves, which are designed to be protected from processes running at higher privilege levels. And what this means is that computations running inside these enclaves are protected against threats like software attacks, even if the operating system, or the BIOS or the VMM or drivers on the machine are compromised. What's running inside of those enclaves also can't be seen by anybody who has privilege level to that machine.
And what are some of the key areas that confidential computing can help enterprises with?
So emerging use cases like privacy preserving machine learning, allowing collaboration between independent data owners on model training, keeping data and IP confidential. These are very much emerging models in the confidential computing arena. Even privacy preserving machine learning in a federated model is emerging. Federated models are very interesting in the sense, if you look at the healthcare market, people don't necessarily want to move healthcare out from where it is. Yes, we'll encrypt it, but we want to keep it in its locality. And in a federated model, you can think of the way healthcare is right now. Most patients have several providers, a GP, a cardiologist, a physiotherapist, for example, and each of these in most countries will have their own systems. So confidential computing has opened the door to what I call privacy preserving federated machine learning, which is allowing the analysis of data to happen where the data resides. So the data in this case doesn't move, only the results go back to a central location of algorithms. And that retains assurance that data is segregated, safe in your environment, and that it's working back in a secure and safe fashion. So instead of trying to combat the problem of moving data to a centralized area, the answer is a federated data model.
And finally, on a more broad level in the cybersecurity space, what are your thoughts on the security skills shortage in Ireland at the moment?
I think we have to continue to build a pipeline of talent, and that's not just through academia. To me, it's about upskilling and cross-skilling existing security professionals in the state to keep them up to date with the increasing changing threat landscape. And as you've seen, as we've talked about with confidential computing, it's an evolution of continuing to try and stay one step ahead. So that threat landscape is constantly changing. Enterprises need to continue to invest in this space, and by cross-skilling and upskilling, we may even be making room for other people to come in at a lower level. I very much believe in the concept of apprenticeships in this arena as well. So a mix of apprenticeships with academia for me is the way forward to address this issue that we have in the state.
Perfect. Thank you very much, Paul.
Pleasure.